on to example B now. So notice that this example here was a little bit different than the ones we had before. These were already all in terms of sine theta and cosine theta. And so we had to use a different technique than rewriting those trigonometric relationships into sine theta and cosine theta, like we had on the other page where we had cotangents and tangents and secants, etc. So we had to use a different strategy. In this case, we used the factoring of difference of squares. Now here's another one, another favorite of mine. So we take a look at the left side. We see that that is sine theta over 1 minus cosine theta. And we've got the right side, which is 1 plus cosine theta over sine theta. So now neither one isn't more, or neither one is more complicated than the other necessarily. But when you have some sort of a sum or difference in the denominator, I usually try to work on that. And when we're dealing with sines and cosines, we're kind of, I sort of want to use the same kind of philosophy as I did over here with the difference of squares, but in this case this has already been factored. So what I'd like to do is I'd like to multiply, you multiply by 1, of course, which is multiplying the same thing top and bottom. So what I would do is I would multiply what would give me a difference of squares. So if I want a difference of squares out of this, 1 minus cosine theta, I'm going to multiply top and bottom by 1 plus cosine theta. So then when you multiply the denominator, and it's more the denominator I'm really worried about at the moment, and I'll just leave this as it is here for now. When you multiply the denominator here, we actually end up getting 1 minus cosine squared theta. Okay, 1 times 1, 1 times cosine theta, 1 times negative cosine theta. Those two terms just drop out, and then negative cosine theta times cosine theta gives us negative cosine squared theta. And by going back to the original formula sheet, you can see then that 1 minus cosine squared theta is nothing more than sine squared theta. And then we can do a little bit of reducing here. So that sine theta reduces with one of those, and now we're left with 1 plus cosine theta over sine theta, which equals the right side. Therefore, sine theta over 1 minus cosine theta equals 1 plus cosine theta over sine theta. Another successful trigonometric identity proven. Okay, on to example C. The left side is sine x times tangent of x. The right side is 1 over cosine of x minus cosine of x. Now, sometimes, and just like I said in the previous two examples, we've been sort of playing around with different strategies and different techniques from the first page. Sometimes it's okay to work on both sides at the same time and simplify down. Okay, so we've seen a few techniques now and a few different processes and procedures. Please pause the video again and work your way through this, and then come back and check out the solution. Okay, so I see we've got a tangent of x here, so I'm going to rewrite that as the sine of x over cosine x. And then if you just expand that through, we get sine squared x over cosine x. Okay, so that doesn't tell us a whole lot just yet. So now let's take a look at this right side. I see I've got a fraction with denominator of cosine x. So what I'll do is I'll multiply top and bottom of this by cosine x so I can get a common denominator. So I end up getting 1 minus cosine squared x over cosine x. And then if we were to look over to this question over here, we see that 1 minus cosine squared x actually equals sine squared x. And therefore, I see now that left side equals right side. And therefore, sine of x tangent x equals 1 over cosine x minus cosine of x. All right, one more page of fun. Let's proceed, please. Example D. Now we've got a fair amount there that is complicated. So again, what I'd like you to do as we set this up, again, please pause the video, go back to your formula sheet and see where you might be able to do some simplifying. Either substitute something, whoops, that's not very nice, one of the identities that you have on the first page, substitute that in to simplify down a little bit. And just see what you can try, or see what you can do. Just try whatever. And if it doesn't work, well, erase it and try over again. There's no harm done. I know it's a lot of time and you like to work through things efficiently, but the more you make mistakes and learn from them, the more pathways you form in your brain and the smarter you actually get. So you actually get smarter by making little mistakes and learning from them. That's the big thing. Okay, so pause the video, please, and then come on back. Okay, so I think this is one of these things where I'm going to have to attack both sides at the same time and simplify down. So I don't really know what's going on here, or how this can help me. So I'm going to do 1 minus tangent of squared x here. And 1 minus sine squared x I know is cosine squared x. So I'm just going to substitute that in. And over here, maybe I'll just switch over to the right side. I see I've got 2 cosine to the power 4x minus cosine squared x. So I see I've got a common base. So I can actually factor out cosine squared x here, which leaves me with 2 cosine squared x minus 1. And that's all over 1 minus sine squared x. Well, hopefully we recognize that by now, that that is cosine squared x. Okay, so things are looking up here. So what I'm going to do is I'm going to cancel out that cosine squared x and that cosine squared x, which will leave me now with 2 cosine squared x minus 1. And that, I'm not sure where that's going to leave me at the moment, but let's just pause there, go back over to the left side, and why don't we try maybe expanding this in, seeing what that will do. And I might actually even try to change this, or I will change this tangent squared x into sine of x over cosine of x. So I'll multiply this into both of these two terms. So I get cosine of squared x minus the sine of squared x over the cosine of squared x. That's from the tangent squared x there. And then I multiply that by the cosine squared x. So I see I can cancel things out here. So there's a cosine squared x, those cancel. And now we're left with cosine of squared x minus sine of squared x. So I think we're pretty close. So can you go back to the first page and check what these two things may equal? And we might actually end up getting close to a finale here for this example. So pause the video and come on back in a couple seconds, please.